Hi, and welcome back to Common Core Algebra 2. 4.4 lesson today is finding equations of exponential functions. Now, you spent some time already with exponential functions in Common Core Algebra 1, so this shouldn't be completely new to you. So I feel like sometimes in some of these problems, a little common sense is all we need. So let's try and use some of that when we're looking at exercise number 1. So an exponential function, let's slide this up a little bit, of the form f of x equals a times b to the x is presented in the table below. Now again, an exponential function, I like to always remember, is when the x is the exponent. Don't get that confused with the quadratic when it says like x to the second power. It looks like an exponential, but that's not. That's a quadratic equation. So when you have a variable or a number being raised to the x power, you know that's an example of an exponential function. So determine the values of a and b and explain your reasoning. So I'm hoping you remember from previous lessons that a is my y-intercept. So if I look here very easily in my table, I can see that right here, 0, 5 is my y-intercept. So I can say that a is 5. Now to find out what b is my common multiplier between these. So I'm just going to erase this point for a second. And I'm going to say, what happens between here and here, and then between here and here, and between here and here? And remembering, you're beginning with 5. So to get to 15, I'm doing 5 times 3. To get to, this is going to be 5. I start my initial now, and I go 5 times 9, and my initial here is 5 times 27. So now I can kind of translate that into my exponential. So 5 times 3 to the first, 5 times 3 to the second, and 5 times 3 to the third. So I can see here that my base is 3. So my final equation is f of x is equal to my base, my y-intercept is 5, my base is 3 raised to the x power. So again, not a lot of math going on there, but some common sense going on there. Write down what you need to and join me in exercise 2. All right, so now we're going to be a little bit more challenged because we're going to look and see what the inputs are as they're being increased by certain values. All right, so let's start with the basic problem. For an exponential function in the same format, we know that f of 0 is 8 and f of 3 is 1,000. So before I even start moving on, I start translating this a little bit for myself. This means I have a 0.08, I have a 0.3 1,000. Helps me just to understand things a little bit better. Use the fact that f of 0 equals 8 to determine the value of a. Show your thinking. I feel like there's not a lot of thinking to think here because 0, 8 is my y-intercept. So you can spend some time here saying, well, 0, 8 is my y-intercept, so show your thinking. So therefore, I have to have f of x is equal to 8 times b to the x power. You can spend some time talking about that because it is asking to show your thinking. If worse comes to worse, you can explain your thinking a little bit, but I don't think there's an awful lot to show there. B says use your answer from part A and the fact that f of 3 is 1,000 to set up an equation to solve for b. So you can solve for b in part C. So we're going to use the other point now to say y equals 8b to the x. So I know that y is 1,000 is equal to 8 times b, and we know that our x is 3. Divide both sides by 8, and I get b cubed is equal to sorry for the pause there. I'm getting a little ahead of myself. It said here, wait, I just finished telling you we're going to solve for it in the other one. So it said to set up the equation, which means we're done right here. See, once you're good at math and you don't even read the directions, you just keep doing what you just naturally know how to do. Because now it's telling us over here we're going to solve for it. So 1,000 equals 8b cubed. Divide both sides by 8. I'm going to just switch it around and say b cubed is equal to 125. Now here you can do one of two things. You can actually show the cube root of both sides if you want to, or you can raise them both to the 1/3 power, whatever works for you. And b turns out to be 5. Now, it didn't actually tell us to write the equation, but D says determine the value of f of 2. So before we start with that, we better write the equation down. So we said the equation looked like f of x is equal to a, which is our y-intercept, times our base, which we found out is 5, to the x power. So if we want to find out what f of 2 is, we're going to substitute in 2 for our x, 5 squared. And we know that 5 squared, of course, is 25. And 25 times 8 is 200. I always like to make sure that my answer is complete when I write it down. We don't have to explain anything. We did the work. Everything's good. Pause and write things down. Rewind if you need to. And meet me at number 3. So an exponential function exists such that f of 4 equals 3, f of 6 equals 48. So again, I'd like to do some translating here. When x is 4, y is 3. When x is 6, y is 48. Which of the following must be the value of the base? So, and it says we can explain or we can illustrate our thinking. I'm a big fan of illustration. So, if we think about our x and y, we have 4, and that is a y value of 3. We have 6, that's a y value of 48. We do not have a y value of 5. So, but we do know that in an exponential function, our base, this times this, 3 times the base gives me this one here. And then the base again times whatever this is times the base gives me 48. So if I just flip-flop this a little bit and just bypass the second one, what do I need to multiply 3 by in order to get to 48? That's right, b squared. I know you were saying that. B squared. So let's set up the equation. I know that 3 times b squared has to be 48. I divide both sides by 3. B squared is equal to 16. And b, I'm going to remind you, it's going to be plus or minus 4. Because both of those numbers, positive 4 and negative 4, both give me 16 as an answer. But because a negative 4 does not give me a valid base, we're going to use the positive 4, and here's our answer right here. Again, just a little common sense. Don't overthink things, because sometimes I think you all just spend too much time, oh, this must be a very difficult problem. Just convince yourself you know how to do it. You know enough information about exponential functions that you can do these. So, exercise 4. An exponential function in the form y equals a, b to the x passes through the 2 points. So this time they actually give us the points. See, so sometimes they give it to us in function notation, sometimes they give it to us just in point notation. By substituting these 2 points into the general form of the exponential, create a system of equations. So what we're saying is, here's the general form. So what we get is y, oops, I'm not going to start with y, I'm going to start with one of our points. Let's use the 236. So 36 is equal to a times b to the 2nd power. And the second one is 121.5 is equal to a times b to the 5th power. B says divide these 2 equations to eliminate the constant a. Recall that when dividing 2 like bases, you subtract their exponents. So what we mean by that is I'm going to divide, and I'm going to put the larger one on top to avoid negative exponents, by the way. 36 equals a, b to the 2nd power, and I'm simply going to divide each one of these. So they're asking us just to go to the point where we eliminate the a's. So bam, we eliminated the a's. So b to the fifth divided by b to the second, we subtract exponents, and b cubed is equal to, and I'm just going to leave it as 121.5 over 36. Because as we do our calculations, leaving things in a little bit raw form makes our answers a little bit more accurate. So moving on to C, which is going to now tell us to solve this equation. We have b cubed is equal to, and if you do that division, you actually come out to be a nice number, 3.375. So, and this is what I was saying before, you can take the cube root, or you can simply multiply by, raise it to the 1/3 power, because that will undo the 3 as well. It means the same thing, but b is equal to, once you're done with that whole thing, you get a really nice number. You get 1.5. So now it says use your value from C to determine the value of A. So again, if you need to pause at this point and just kind of comprehend what can't talk, just what happened, you can do that. But remember, what we're starting with is we're going to use the other point, one of the points. Let's use 2, 36. All right? So we know that the equation of our line, of our exponential, is y equals a times b to the x. So 36 is equal to a times b to the second power. So you get, after you do all of this out, you get 36 is equal to 2.25 times a. Divide both sides by a, and a turns out to be 16. So the last thing we're going to do is state the final equation. Make sure you double check that you answered every question embedded in each question. So our final equation is f of x is equal to b, which is 1.5, which is a, which is 16, times the base, which is 1.5, raised to the exponent. Okay? Write down what you need to, and meet me at number 5. Okay, number 5 and number 6, kind of the same question that we just did. So I'm not going to spend a lot of time on this. I'm gonna write through number 5. So I want you to pause. I want you to try it on your own, and then go back and look at the answer and see if you can make sense of it. Okay? So I'm going to put the mic down and kind of just work through it. And if you have questions, bring them into me tomorrow. just be careful when you're doing these to be aware of the negative exponents, because 2 minus a negative 2. All right, by the way, I'm looking right here as I'm talking. Right here. All right. When you subtract 2 minus negative 2, that's a positive 4. So that gave me that 4 that was right here, in case you were wondering. Okay? So hopefully, the arithmetic here might have been a little difficult, but the rest of it should have been easy. Okay? And 6 is kind of the same thing. So let's talk through 6 quickly. Whoops. It's here. Just down here somewhere. A bacterial colony is growing at an exponential rate. It is known that after 4 hours, the population is 98, and after 9 hours, it's at 189. Determine an equation in the form that models the population y as a function of the number of hours. This is a great application, and what you're really getting here is 2 points. You have hours, right? And you have the population. What do we call population? Shall we go with just P for now? But that's basically going to be our function. All right, so this is our x and our y. So what are our x and y's? We have 9, 189, and our first one was 4, 98. So we can do exactly what we just did. Set up the 2 equations. So we have 189 equals 9. I'm sorry. This makes me crazy. A times 9 raised. It's been a long day, guys, okay? So let's try this one more time. 189 is equal to a b to the 9. The second one, let's try this one. This one is 98 equals to ab to the 4th. And we simply divide these two. Again, I always like try to make sure that exponent of my b is larger up on top. So once you're done with this, you get the a's cancel out, right? So you get b to the 5th is equal to 189 over 98, which actually turns out to be a really crazy big number. But I'm going to write down the whole thing because rounding too soon is a problem. All right? So now we have that. So we have, now let's use one of the points. So let's use 98 is equal to a times that whole big crazy number, 1.14037576 raised to the 4th power. Once you solve this whole thing, a turns out to be approximately 57.947. So for ease of calculation, we're going to say a is equal to 58. It doesn't say to round it here, because what it's actually asking here is what percent is the population growing per hour. But we don't want to round it too soon. But I think we're pretty safe doing that. So writing down the equation now, we know y is equal to 58, got to finish up, 1.14 raised to the x power. So if you remember about exponential functions, this is the growth rate. It's increasing by 0.14. That's the rate, but it's asking us for the percent. So the percent would be 14%. Okay? So it asks us to determine, I'm just looking, it says determine the equation. So we did that. That's right here. So we answered both the questions that were embedded in that question. Again, before you work and you spend time on this, you read it first, you do the math, you go back and you read it a second time. All right, take your notes that you have to. I'm done for now. Honors kids are coming in, and I will see you tomorrow. Make good choices.
Hello, hello, hello. Hello.